So, good day everyone, and now we are going to discuss the fourth topic of the chapter 12, which is the greenhouse gases. So, what is greenhouse gases? So, greenhouse gases are gases in the Earth atmosphere that absorb the emit infrared radiation, trapping heat near the surface and causing the greenhouse effect. So, it means the greenhouse gases are special gases in the atmosphere that can trap heat. And when the sun energy reaches the earth, some of it is supposed to go back into space. But greenhouse gases absorb this heat and keep it near the earth's surface, making the planet warmer. And this natural process is called the greenhouse effect. As early as 1859, British engineer John Tyndall wrote, "As a dam built across a river causes a local deepening of the stream, so our atmosphere thrown across the terrestrial or infrared rays produces a local brightening of the temperature at the Earth's surface." So this sad analogy by John Tyndall, it compares the atmosphere to a dam. When a dam blocks a river, the water piles up and it becomes deeper. In the same way, the Earth's atmosphere blocks or traps infrared rays or the heat that are trying to escape into space. Because this heat cannot escape, it builds up near the Earth's surface. This buildup of heat causes the temperature on Earth to increase. This is what we call the greenhouse effect. So, the said quote or the analogy explains how the atmosphere acts like a barrier that traps heat and warms the planet. So, in short, just a dam traps water, the atmosphere traps heat, causing the Earth's atmosphere to in the 19th century, scientist John Tyndall discovered that water vapor was the most common greenhouse gases in the atmosphere, while carbon dioxide was present only in a very small amount. And at that time, factories were not yet common, so burning coal did not produce enough carbon dioxide to be a major concern. And still, Tyndall worried about what might happen if industrialization, the shift from farming to machine-based production, must grow bigger. When we say industrialization, it means more machines, more electricity use, and more coal being burned. So, 100 years later, the world changed. After World War II, many countries became heavily industrialized, and the amount of the carbon dioxide in the atmosphere increased sharply. And this rise in the carbon dioxide made scientists wonder whether it was affecting global temperatures. And one scientist, which is Charles David Keeling, decided to find out. Charles David Keeling measured carbon dioxide levels far from cities in Mauna Loa, an extinct volcano in Hawaii. To measure, um, Charles David um, Keeling used Keeling curve. So when we say Keeling curve, it is the measurement created by Charles David um, that showed the steady rise of carbon dioxide in the atmosphere over time. And now, um, that is the Keeling curve that Charles David Keeling used. So this graph shows that the concern of engineer Tyndall in the mid-19th century and Dr. Keeling in the mid-20th century were well founded. Um, the carbon dioxide concentration has gone up and the temperature has also risen. And these findings are the solid proofs of the global warming. Now, let's go to let's dive into the greenhouse effect. So what is greenhouse effect? So when we say greenhouse effect, it is it works like a blanket around the earth, just as a greenhouse keeps plants warm by trapping heat. These gases trap some of the sun's energy so that it does not escape back into space. This natural process keeps our planet warm enough to support life. And now, the history of the greenhouse effect. So, the idea of the greenhouse effect has been studied for almost 200 years. It started in 1824 when Joseph Fourier suggested that the Earth stays warm because certain gases in the atmosphere trap heat, similar to how a blanket works. And a few later, in 1827 and 1838, Claude Pilot support Fourier's idea with more scientific evidence. And then, in 1859, Jean Tyndall proved through experiments that gases like water vapor, and carbon dioxide can trap heat. This was an important discovery because it showed exactly which gases warm the Earth. And in 1896, Svante Arrhenius went further by calculating how much the Earth's temperature would rise if carbon dioxide increased. The work of Svante Arrhenius made the greenhouse effect more understandable in numbers. And the word greenhouse effect was first used in 1801 by Niels Gustav Ekholm. Enough, I even though earlier scientists had already described the idea. And then, by 1917, Alexander Graham Bell warned that burning too much fossil fuel could make the Earth hotter through a greenhouse effect. Alexander Graham Bell also encouraged using cleaner energy like solar power. And now is the mechanism. The sun gives energy to the earth in the form of sunlight. Some of this energy warm the earth, and about 45% of it goes back to space. The rest stays in our atmosphere. In the atmosphere, we have greenhouse gases like carbon dioxide, water vapor, and methane. These gases act like a blanket around the earth. They absorb and reflect some of the heat, keeping it from the escaping into space too quickly. This natural process is called the greenhouse effect. It helps keep the earth warm enough for humans, especially plants and also animals to live. If we did not have greenhouse gases, the earth would be extremely cold. The coldness is about 18 degrees Celsius, which is too cold to support life. So, the greenhouse effect is important, but too much of it, because of the pollution or etc., leads to global warming. The greenhouse gases are also have a role in the climate change. So first is the water vapor. The water vapor is the most abundant greenhouse gas, but importantly, it acts as a feedback to the climate. The water vapor increases as the Earth's atmosphere warms, but so does the possibility of cloud and precipitation, making this some of the most important feedback mechanisms to the greenhouse effect. And next is the carbon dioxide. So the carbon dioxide, it is just a minor but very important component of the atmosphere because carbon dioxide is released through natural processes such as respiration and volcano eruptions, and through human activities such as deforestation, land use changes, and burning fossil fuels. And next is the methane. Methane, it is a hydrocarbon gas. produced through natural sources and human activities, including the decomposition of waste in landfills, agriculture, and especially in rice cultivation, as well as ruminant digestion and manure management associated with domestic livestock. And next is the nitrous oxide. The nitrous oxide is a powerful greenhouse gas produced by cultivation practices, especially the use of commercial and organic fertilizers, fossil fuel combustion, nitric acid production, and the biomass burning. Next is Next and the last is the chlorofluorocarbons. The chlorofluorocarbons, it is a synthetic compounds entirely of industrial origin used in a number of applications, but now largely regulated in production and released to the atmosphere by international agreement for their ability to contribute to destruction of the ozone layer. And so there are five effects of the greenhouse gases. So first is the weather, the sea level, the farming, the plants and animals, and especially to the people. So the weather, for the greenhouse effect, most of the areas will warmer, and there are some also areas will become cooler, and in that time, there may be many storms, floods, and drought. And also, no one can predict which will the area will be affected. And next, in the sea levels, higher temperatures will make the water of the seas and oceans expands, and ice melting in the Antarctic and Greenland will flow into the sea. All over the world, sea levels may rise perhaps by as much as 20 or to 40 centimeter by the beginning of the next century. Next is the farming. So, and, yes, the changes in the weather will affect the types of crops grown in different parts of the world. So some crops such as wheat and rice grow better in higher temperatures, but there are also other plants such as maize and sugarcane do not grow in a higher temperature. And next is the plant and animals. So it has taken millions of years for life to become used to the conditions on Earth. As the weather and the temperature changes, um, the home of plants and animals will be affected all over the world, and many animals and plants may not be able to cope with these changes and could die. And lastly, to the people. So yes, the changes in climate will affect everyone, but some populations will be at greater risk. So the effect on people will depend on how well we can adapt to the changes and how much we can do to reduce climate change in the world. To avoid the effect of the greenhouse gases, there are um, 7 ways to reduce the greenhouse gases. So first is the 3 R's, which is the reduce, reuse, and recycle. I know that all of us are familiar in this um, 3 R's because since elementary and high school, especially high school, we are kind of like we encounter this word. So um, buying products with minimal packaging will help to reduce waste. By recycling half of our household waste, we can save 2,400 pounds of carbon dioxide and wali. And next is use less heat and air condition. So adding insulation to our walls and installing weather stripping or caulking around doors and windows can lower our heating costs more than 25% by reducing the amount of energy we need to heat and cool our home. And the third one is the replace your light bulbs. So wherever practical, replace regular light bulbs with compact fluorescent light bulbs. I'm replacing just 160-watt incandescent light bulb with a CFL will save us over the life of the bulb. And the fourth one is the drive less and drive smart. So less driving means fewer emissions, and also besides save it can also save gasoline, and also through walking and biking, it is also good for our health because it is the great forms of exercise and also to maintain our healthy lifestyle. And that's the fifth one is to buy energy or the efficient products. So home appliances now come in a range of energy efficient models, and compact fluorescent bulbs are designed to provide more natural looking light while using far less energy than standard light bulbs. And the sixth one is plant a tree. So planting trees can also avoid greenhouse gases. So if we have the means to plant a tree, so what we have to do is start digging because trees can absorb carbon dioxide and give off oxygen. A single tree will absorb approximately 1 ton of carbon dioxide during its lifetime. How about more if we plant more trees? So, and the last one is encourage others to conserve. So, share information about recycling and energy conservation with your friends, neighbors, or especially your co-workers if you are on the job, and take opportunities to encourage public officials to establish programs and policies that are good for environment. Would be all. Thank you, and I hope you learned something.